All right, there we go.
Yeah,
Sorry about that.
that's okay.
You had a good couple of weeks?
Yeah, I did.
Good, 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 good. And how's math going?
It's going great.
Is it?
Yeah,
Cool. Yeah, do you have anything that you need to work on?
yeah, I do. I'm just gonna send you it right now.
Okay. Email or chat?
I can I think I can like put the link in chat.
Okay, that's cool. Okay, yep, I've got it. Okay. You shall not pass. Sign into your doc hub. I might not have permission to view this page, so
I could screen share.
yeah, let's do that. All right, let me get my,
Oh, no, I think that's the wrong page. Oh, it's loading. There it is.
it's the wheel of death spinning.
No, it's there.
Oh, okay. All right, so, oh, we're doing these awesome things.
Yeah,
Okay, I got you. So these are geometric means and proportions and a whole bunch of fun stuff like that.
yeah.
Okay, any more than this page?
No, it's just this.
Okay, all right. So do you know these relationships, Luke?
Uh, yeah, I kind of do. I have them written down right here.
Okay. And are you going to be able to have the formulas on a test or whatever?
No, but I'm gonna try to like memorize them tonight.
Okay. They kind of, once you get going, in a weird way, they start making kind of makes sense.
Yeah.
All right. Let me see. Okay, so I think what I'll do is I'll just start cutting out pieces and parts, like maybe we'll tackle this first. Okay, so we got two chords intersecting in a circle, right?
Yeah.
And you know the relationship when that happens?
Uh, Not really, but can you like go over
Sure.
it? Yeah.
Sure. So without proving it, and I hate not proving it because it I don't know. I don't like things to appear to be magic or whatever in math.
Yeah.
But it would take a bit. And your teacher hopefully proved it to you in one way or another, but just know that it's not, you know, some miracle.
Yeah.
That this is true. You're smart enough to know that. Okay, I don't want it to be dashed. Okay, so that's, do you know what a chord is when I say chord?
Yeah, I do.
Okay, cool. So if two chords cut each other inside of a circle, then what they do is cut off segments that are proportional. So, but we don't have to really use proportions. But what after you, what it comes down to is the segments that are cut off, like A times B is equivalent to C times D.
Okay.
Okay, so all you have
Yeah.
to do, yeah, it's pretty straightforward then, right? You just have to make sure you use the pieces of one particular chord when you're multiplying. So like for number 3, it would be 12 times X is equal to 10 times 6.
Yeah,
Make sense?
yeah, it does.
Okay. So then off we go, right? 12x equals 60. Divide by 12. And x equals 5.
Yeah,
Okay. All right. So you want to try the other ones, and then I'll sort of stay silent and see how you
Yeah.
do. Doing all right?
yeah.
Okay, I'll work them out silently here so you can check your work as we go, okay?
Okay.
Have you all had spring break yet?
No, not yet.
When's that? Coming
I
up?
think in like a few weeks.
Okay. Is it 1 week or 2 week spring break?
I think it's like a 2-week spring break.
Nice.
Yeah.
Let's see. I got 23.
Yeah, I got it.
Okay, cool. Okay, then the fun begins.
Yeah.
Couldn't just be linear equations, could it? No. Evil people. You still working on 5 or did you move to 6?
I moved to 6.
Okay. Did you get this for 5?
No, I didn't.
Okay. So did you get, let's see, x times x plus 8 equals 8 times 6?
Yeah,
Okay, and then, I mean, how far along did you get as far as I went?
I just made, I said, I put x equals 0 for some reason.
Oh,
Oh, wait,
okay.
no. Yeah,
So when you have a quadratic, you're gonna have to factor it or use the quadratic formula, right? You're gonna have to
yeah.
move the 48 over, right?
Hmm.
And then do you see how I factored it?
Yeah,
Are you comfortable with factoring quadratics?
yeah, I am.
Okay, that's good.
I just forgot I had to do that.
Yeah. The quadratics never go away
Yeah,
until you're done with math, ever, ever, ever. Okay, so I'm going to tell you that one of these answers is not valid. So you got -12 and 4 as well.
-12.
For number, -12 is not valid, is what you're saying?
Wait,
Or
I'm just confused on the left one.
I'm sorry, confused on what?
The last part of 12.
Okay. So are you okay with x plus 12 times x minus 4?
Yeah,
Okay, so then what we have is the zero product principle, and all that means is if I got two things being multiplied, right? It looks kind of weird because there's an x, but I've got this guy times this guy, right?
yeah,
Okay, so do you agree if I have two numbers, if either one of them is equal to 0, then the product or the answer would be 0?
yeah.
Okay, so then I just have to figure out, okay, what makes this first guy 0? So I set it equal to 0 and I solve it. Right? So x would be -12. And if you think about it, right, you plug that right back in there. -12 plus 12 is 0, and then 0 times anything is 0, right?
Yeah,
And then you have to do the same thing for the other factor. Add 4 to both sides, and then x equals 4.
okay.
Is that cool?
Yeah,
Okay, now the problem is that -12 is invalid because these x's represent lengths.
yeah.
Okay, and you can't have a negative length, right?
Mm-hmm.
So we have to cross that out. And the only valid answer is 4.
Okay,
Of course, if this was just solve the quadratic, -12 is perfectly fine. Okay.
okay.
All right. All right. So, okay. I get 5.
Yeah, I got 5.
Cool. Okay. So let's move on to the next set. So I'm going to try and find a nice picture. Okay, 1 second. I'm trying to get some nice drawings.
Okay.
Okay.
So it's just like the same thing like the other one, but it like looks different.
Yeah, it's similar. So those guys are secant lines, right? Or well, a secant and a tangent, actually,
Yeah.
right? So I thought I had a nice picture. No, 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 sorry. I'm getting the wheel of death. Okay, so yeah, we got that one. I'm gonna make you a picture with all the relationships on it.
Okay.
Okay, so and I'll clean it up a bit too. So that's what we just did.
Yeah.
Okay, and this is a secant. Our next set is a secant tangent thing. So let me get that on a new page. Secant tangent and secant secant. Okay. And one more. Okay, so here's all the relationships, and these are giant. So I'm going to make them smaller. And you know what a secant is and what a tangent is?
Yeah.
Okay. So a secant intersects a circle in 2 places, right?
Yeah.
And a tangent just touches the circle. Can you still see that okay?
Yeah, I do.
Okay, cool. And then let me get this other ginormous thing, just so we have everything on the same page. Okay, so this is, again, this is what we just worked on. The 2 chords in a circle where the segments they cut off. Do you follow the labels okay? That like
Yeah, I
E
do.
times EC. Okay, cool. All right, and so here's the relationships for secant and secant tangent. So if you, and I'll just keep this there. Sorry, I keep moving around. I kept getting indecisive. So basically, if I have 2 secants, then the length outside of the circle multiplied by the entire length, right? So PH times PG is equal to the same product of the other secant, like the little piece
Yeah.
times the entire length. Okay.
Yeah.
Okay. And so with secant tangent, it's really the same thing. Okay. If you start with the secant part, it's still the part outside, the external part, So that is EC, that's this part right here, times the entire length, which is ED. You okay with that?
Yeah.
And so the tangent is like kind of a obnoxious secant in that it only touches it once. So it's like the outside part times itself again, because it doesn't have an inside part. So it's EA times EA or EA squared. Is that okay?
Yeah.
Okay. So then if we take these guys back over here, so we have them for this question. Actually, I thought some of them were tangents, but these are just the secant ones. So we'll just take the secant one with us. And off we go. So I'll do the first one, okay?
Okay.
Just to be sure, right? And so we got this guy right here. Okay, so for 7, I'll start with the top one. It's the outside segment 6 times the entire length, which is 10 plus 6 or 16,
Yeah.
is equal to the outside segment 8
Times 8 squared. I mean 8x.
Well, if we find the lengths, we don't multiply. If we don't multiply them, we add them, just like we
Oh.
did 10 plus 6 is 16.
Oh yeah.
Makes sense?
Yeah, yeah, that does.
Total common error. And then off we go, right?
Yeah.
So then let's see. 6 times 16, 6 times 10, 60. 6 times 6 is 36. So 60 plus 36 is 96. And then the fun begins, Luke. Here we go.
Yeah.
I can't think of anything more fun right before the weekend. In fact, I think I'm going to do this all weekend, Luke.
Yeah. Sounds like fun.
I have missed it. You know what I'm saying? It's been a while since I've done secants and stuff. This is living. That makes sense?
Yeah.
All right. Give number 8 a whirl and then let me know when you're done, okay?
Okay.
All right. And I'm skipping step solving the equation a little bit. Are you okay with that?
Yeah, that's fine.
Okay.
Do you want me to do all of them or just 8?
Just 8, and then we'll stop and make sure you're doing okay. And then
Yeah,
we'll,
I did number 8.
okay, so then it should have been, let's see, 5 times 12
Yeah.
equals x times x plus 4.
Yeah.
Okay, so now we got a little bit of trouble here because we're going to have another fun quadratic, x squared plus 4x. That's what happens when the variable's on the outside. So then we're back. I'm sorry?
Yeah, I got that.
Okay, so then we're going to subtract 60 and get x squared plus 4x minus 60. Is that okay?
Yeah.
Then we got a factor like it's 1999, which makes no sense whatsoever. So I get X and X. And did you get these off the top of your head? I never can when I'm always like, okay. 2 and 30, factors of 60. Oh my God, 6 and 10. Oh my God. 6 times 10 is 60, right?
Yeah.
Are you just gonna let there and watch me suffer? Is that what you're gonna do?
No, I'm just bad at doing it too.
Oh, okay. Did you not get it?
No, I didn't.
Okay. So what I do is I just keep going. 4 times 15, right?
Yeah.
And then 5 times 12. And I'm looking, I gotta find something that subtracts to give me 4, right?
Yeah.
So finally, and which I should have thought of this first, 6 times 10. Like if it doesn't come to me right away, I just start listing the factors out. And then I see, oh, okay, it's 10 and 6 for crying out loud. I was kind of hoping you were just letting me suffer, right? I'm going, all right, that's cool. Make the old guy suffer a bit. Okay, so this would be plus 10 and minus 6. Because we
Yeah.
need this 4 to be positive. Are you on board with that?
Yeah.
All right. So then we do this whole thing. And then X equals negative 10. X minus 6 equals 0. And then X equals 6. Yeah.
Yeah.
And then we got to throw out the negative because you can't have a negative distance.
Yeah. So it's 6.
Good.
Yeah.
All right.
I
So
think I did it wrong, but I got 6. I think it's just a coincidence though.
probably
Yeah.
did you get the factors wrong?
No, I didn't do the I didn't make it equal 0.
Okay. Um, X times X. Yeah, I'm not sure what you did, but with the quadratic, you always have to set it equal to 0 and then factor. And if it's not factorable, then you get to have fun with the quadratic formula, negative b plus or minus square root of b squared, blah, 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 blah. That awesome thing.
Yeah.
Okay.
Okay, I'm gonna try to do number 9 now.
Okay. So with number 9, I want you to, once you get your equation written, let me know, and then we're going to check that because it's a little, might be a little bit of a tricky one. We'll see.
Okay.
So I just want to make sure we're starting out okay.
Yeah, I got it.
Does that make sense?
Yeah.
All right. So I'm going to go ahead and go with each step along the way, and just go ahead and work. And every time you get a new line, check your work against mine, I guess.
Okay.
This is a little wonky. And then let me know when you get to where I've stopped. Or if you have any questions before that, of course.
Wait, on the last one, isn't
Yeah.
it supposed to be negative 6x?
Let's see. So x squared plus, so this plus 2x is correct, right?
Yeah.
Okay, so that's a positive 2 and a negative 4 combined to be a negative
Oh,
2.
I thought it was a negative 2.
Yeah.
That's why. Okay.
Yep, I get that.
Okay, yeah, other than that, I got it.
Okay. So factoring this, and what do you think we should do to start? Or if you don't know, then that's fine as well.
4 and 10 for 40.
Good, but the problem is we've got this 2 here, right?
Yeah. So 2 and 20.
I think that the easiest way, like we could sit here and play with it, but the easiest way and the first rule of factoring is there anything that is common to each term that I can factor out? And
Yeah,
they're all the coefficients are divisible by 2. So I can make my life a bit easier if I factor out a 2 first. Does that make sense what I did?
Yeah.
Okay. So now I don't have to deal with the 2. It's just sort of coming along for the ride. And then I'm going to do my thing like we've been doing before.
So 4 and 5.
Excellent. And which is going to be positive and which is going to be negative?
I'm not sure.
Okay. So when you're factoring, you are looking for, of course, the factors of the last guy, which you got them. And since 20 is negative, I need the signs to be positive and negative because a positive times a negative gives me the negative here. Like if I were to work backwards and FOIL it. So I know that this one of the numbers is going to be positive and one's going to be negative because of that. And you also remember when you FOIL that the middle terms determine this guy, right?
Yeah.
And it's negative. So I need a -5 and a +4 to end up being a -1x. Because -5 + 4 is -1.
Okay. Yeah.
Is that okay?
Yeah.
Okay. So that's how it works out that way.
Okay.
Okay, so now we're still setting each of these factors equal to 0, right?
Yeah.
2 equal to 0 doesn't make sense, right? So
Yeah.
I just totally ignore that. By the way, I almost said totes ignore that. Have I explained, like I have this thing to say totes to make your species being teens like cringe. And I've done it so often that I just say it and I don't know I say it. So please don't judge if I say it and don't acknowledge that I said it.
Yeah, it's okay.
0 equals x minus 5 and 0 equals x plus 4. And off we go, right? Holy smokes. And then of course 4 goes away, right?
Yeah.
I'm sorry, -4. 10 looks to be easier, just bigger numbers. So let's try and knock that one out, I guess.
Okay.
Any fun plans for the weekend where the weather is always beautiful? Is the weather always beautiful where you are?
Yeah, pretty much.
Yeah, well, good for you. Okay. All right, this is totally calculator time. Did you get to where I am?
Yeah.
All right, so I cannot imagine that your teacher would expect you to factor this by hand.
Yeah.
Um, so what kind of calculator are you allowed to use in class?
It's like the Texas Instruments one.
Oh yeah, that's right. You showed me that last
Yeah.
time. Sorry, 3, 4, 5, 6. Okay, so wow, I need numbers. So this is negative, right? So when I do factor it, there's going to be a positive and a negative. But I'm not even going to try that, Luke, just because there's so many factors of these guys. I'm going to go ahead and say, let's use a quadratic formula and we'll use our calculators.
Yeah.
Do you remember or do you have that memorized or no? The silly quadratic.
No, I think I forgot it.
So it's this guy, negative b, ringing a bell.
Oh yeah, yeah.
So this will work for any quadratic like this. So if you ever get stuck factoring, right?
Yeah.
If you know this, then you can just plug everything into here. And of course, this is for a quadratic in the form of ax squared plus bx plus c. So in this particular one, a is equal to 1, b is 45, and c is negative 2079. Is that all right?
Yeah.
Okay, so then away we go. And I messed up. That's not plus 4ac, it's minus 4ac. I don't know why I put that there. All right, whoever wrote this question should be fired.
Yeah, they should.
All right, are you okay with all of this nonsense here?
Yeah.
All right, so then we just got a bunch of calculator work to do. I'm gonna go ahead and do everything under the square root first. See if we get the same thing. Wow. I get 10,341.
Yeah, I did too.
And I was hoping it was a perfect square, which it's not. Okay. X times X plus 45. We didn't do anything stupid, did we? 27 times 77 is 2079. Did you got that too, didn't you?
Yeah.
Okay. And then we subtract it. Negative B, negative 45, 45 squared minus 4 times 1. Yep, that's it. Okay. So, Luke, what we get to do now, there are two answers here, right? It would be
Yeah.
negative 45 plus the square root of this horrific thing divided by 2. And then I say we don't even do the negative one because we know it's invalid, right? Because
Yeah.
things can't be negative. So let's just do this, and then I'm gonna crawl under my desk and cry. And I got X about equal to 10 point, nope, not 10. $28.3.
Yeah. I got it.
Oh, good. So we're dogs sitting my mother and father-in-law's psychotic Boston Terrier. And, you know, terriers have that like smush face, and he's behind me having breathing issues. He's like, so I just turned around to check on him, and he's happy as a clam on his back, scratching it. Okay. Having more fun than we are.
Yeah.
Okay. Let's do this. And then the long nightmare is over, I think. And I'm going to get the formula for this guy for us. Or did I put them all over here? Sorry. There we go. So this is the tangent one. I'm just going to give us some room here. So this is, it's the same thing with the secant,
Yeah.
but it's just the tangent is times itself. So it's always going to be squared. Okay, so for number 11, put him off to the side, actually. I'll just tuck him away down here. Okay, so for 11, it's going to be 9 times 16 as usual.
Mhm.
Is going to equal x times x. Having trouble with the software. All right. Got it. Which actually is fantastic news because we get, let's see, 144, I think.
Yeah.
Right? And so we take the square root of both sides. And remember, when you're solving an equation, if it's just a plain old equation, and you take the square root of an x squared and the square root of the other side, you always put plus or minus, right?
Okay. Yeah.
Because plus or minus 12 is equal to x, because it's true that 12 squared is 144, as well as negative 12 squared is 144. But we have to remember, when we're in a context problem with lengths or whatever, length can't be negative. So our only answer is the positive one.
Yeah.
You okay with that?
Yeah, I'm good with that.
All right. So go ahead and try 12. And I'll work on it silently and we'll see how we do. And this is another fun one. And I'm not going to put us through this. Let's just say that I just cheated and used the internet.
Mhm.
It's not factorable. Okay. So if we use the quadratic formula, I'm just going to say by quad formula, and you can have fun with it if your teacher is going to make you do it. I get x, I didn't get it, the internet got it, as equal to negative 30.7, or x is equal to 18.7. And of course, we throw out negative 30.7. Is that okay?
Yeah.
I'll be interested to see what your teacher. I mean, you have to use a quadratic formula, or if he teaches you how to do it with graphing. All right, so let's do 13 and 14.
Okay.
Or we'll do, we'll do them one at a time, just like before.
I got x equals 4.
Excellent. Wasn't that pleasant?
Hmm.
All right. 14. Same deal, right?
Yeah.
And do you remember what a radical squared is equal to? Or how you deal with that?
No, I forgot.
Okay, so just a quick little refresher. Square root of 3 squared is a square root of 3 times a square root of 3, right?
Yeah.
Which would be the square root of 9.
Yeah.
3 times 3, which is 3. So the square root of anything, let's just say k squared, is always going to be equal to whatever's under there.
Okay.
Always, always, always. So it's a pleasant sight.
Yeah. So x is equal to 1.
There you go. You feeling okay about this stuff?
Yeah.
Now there was a, did you have to do the word problem too, number 15?
Oh, no, I don't.
You don't have to do it, or you're not sure?
No, I don't have to.
Okay. All right. It's just finding what they did wrong.
Yeah.
15 and 16. All right. Okay. So let's see. Do you feel better, a little bit better about your factoring skills?
Yeah.
Because it's easy to get rusty on them for sure. I'm trying to think if there's anything else we should point out here. I don't think so. Do you know when your next test is?
My next test is, I think, like next week.
Okay, so I think, when's our usual day? Is it Wednesdays?
Yeah, Wednesday.
Wednesday. Okay. All right. So if you have any, I don't know, like if your test is, let's say your test is Wednesday or something, just let me, let me know, and I'll try and move you into Monday or Tuesday if you have any
Okay.
questions or anything.
Yeah.
Okay. Sound like a plan?
Yeah, that sounds good.
All right. Have a great weekend, Luke. Good to see you again.
Yeah, you too.
All right.
Thank you.
Bye-bye.
Bye.